So take a look at this diagram. This is called a population pyramid. And you can see it's called a population pyramid because it has this nice pyramidal shape here. On the left-hand side are males, on the right-hand side are females, and you can see that there are lots of males and females in 1950 up here between the ages of 0 and 4. And as you go up, it begins to drop off a little bit between 5 and 9, 10 and 14, etc. Quite a few in the 25 to 29 age range. And then as we go further up this pyramid, you can see fewer and fewer people. So that was in 1950. Let me show you what it looks like in 2020. In 2020, so last year, it looked something like this. Again, lots of 0 to 4-year-olds, lots of everybody actually, and one of the things that you can really detect a difference in is lots of older people. So you can see lots of folks between 70 and 74, a whole lot of people between 80, I should say over the age of 80. In fact, that's one of the fastest growing demographics going on right now. Now, if we extend this out to 2050, you can see what it will look like. It doesn't make sense to call it a population pyramid any longer because it's not pyramidal at all. In fact, you can see a really sizable group of 80 plus folks, octogenarians up here, and so forth. So this tells us that not only in the United States, but in the world, the population is aging. There's a whole lot more older folks out there than there ever were. So about 14.5% of the US population is over 65. About 27% of the population is over 50. And it's about 50 when we start experiencing things related to visual decline. In 30 years, the number of people who are 65 plus will be somewhere around about 70 million people. And over 85 years old is the fastest growing segment of the US population. So this tells us something pretty interesting. We're going to have to learn to design for people who have some visual deficits potentially. Of course, as we get older, we'll tend to stay active longer and things like that. So those are good. That's good news. However, it doesn't necessarily apply to our vision. Hopefully it will. Our vision will be better, but we can't count on it. So let's look a little bit at some of the things that happen as we get older. One thing that happens is there's a decline due to changes in our eyes' optics. So less light enters, entering the eye actually reaches the photoreceptors on the retina. One of the things that happens is the lens becomes yellow, it becomes more opaque, making it difficult to discriminate blue colors. And remember, blue text, fine blue text is already bad because there's so few blue cones in the fovea. Now here's a situation when our lens becomes yellow and it filters out some of the things that enable us to discriminate blue colors. A second is the pupil itself tends to shrink, allowing less light to enter the eye. So here's an example. This is pupil size by age. Here you can see when you're 20 years old, your daytime pupil size, diameter basically is 4.7 millimeters. At night, remember, we're trying to get more light into our eyes, so it's 8 millimeters as the eye dilates a little bit, and the differential is 3.3 milliliters. But you can see it begins to change even by the time you're 30. Already, during the day, your eye is only 4.3 millimeters in diameter during the day. At night, it's 7 millimeters diameter, and the difference is less than when you were 20. By the time you're 40, it's really changing. By the time you're 50, it's changing even more. By the time you're 80, they're almost identical. During the day, it might be 2.3 millimeters, about half the size it was when you were 20 during the daytime, and about a third the size it was at nighttime when you were 20. And the difference between these two things is really little. So this tells you that our pupil size ends up getting smaller as we age. So less light is actually reaching the fovea, which is where we're trying to focus the light energy so we can see. Here's an example of what that might look like if we were to extend this to a picture. What you can see here at 20 years old, that amount of light would be getting, this amount of light would be getting into your retina when you're 80 years old. Now, you don't really perceive things as being this dark and gray and dank and so forth, but that's kind of what's entering into your retina at this point. You don't see this because, as we mentioned before, your brain is doing a lot of the work in top-down processing to make up for information that's being lost in bottom-up processing. Here's another change. Contrast sensitivity changes with age. So we mentioned that the ability to see the foreground and discriminate it from the background is really important for us. So here's an example using a baseline of a 20-year-old. This graph shows the factor by which contrast has to increase in order to keep the same visibility. So you can see at 20 years old you need sort of 1 unit of contrast, but it's already requires say 1.25 or so by the time you're 35, you know, a little bit higher by 40. By the time you reach about 60, you begin to see this elbow in the graph here. Here we're about 2, but by the time you're 65, you're already up to 3, a little bit more than 4 by the time you're 70, and by the time you're 75, you're up at 6 times as much contrast you need in order to detect the same difference. Also, as we get older, our eyes tend to adjust to light and dark more slowly. So for example, when we move from a light to dark or dark to light, like driving into a tunnel, it takes a lot longer for our eyes to adjust. Also, because we get little, you can sort of think about them as micro cataracts on our eyes don't, basically forces light to scatter when they reach our lens. That produces lots of glare. So when the eye is adapted to a light level more intense, light produces glare. And this occurs mostly at night, often while driving, for example. And also the clouding of the eye's optics tends to produce more of that scatter and more of that glare. A second one is, or third one I guess in this case, motion perception. Basically, you may have seen this where you are behind some older person when you're driving, for example, and one of 2 things ends up happening. So they're about to take a left-hand turn, and there will be oncoming traffic, and one of 2 things will happen. Either they'll take forever to decide to take that turn, even when traffic is way far away from them, or even worse and really scary is they'll turn almost right in front of traffic that's coming really fast. One of the problems is the motion perception that they had when they were younger isn't nearly as good when they're older. It's much harder for them to determine how fast something is moving towards them. And that's exactly what's causing this difficulty. Either they're concerned that that traffic that's far away is moving faster than they realize, or they make the other mistake that is they assume that it's not moving that fast and turn in front of it anyway. Another problem is simply a restricted field of view. Our visual periphery ends up sort of diminishing as we get a bit older. So we lose our ability to see information in our visual periphery. And as a result, that makes it difficult to detect a car cutting across an intersection or pulling out from a parking space or a pedestrian walking across the street, that kind of thing. Another issue has to do with response time, although it's not the biggest issue as a lot of people would think. Older people are slower to respond when driving, but not a whole lot slower to respond. About 0.2 to 0.3 seconds slower in a reaction time task. And as tasks become more complex, that effect might be bigger. But actually often it's visual perception that tends to make them slower. Basically, it takes them a little bit longer to see things and so forth, and as a result, it's not the reaction time that's slowed down, it's the perception time that's slowed down. As I mentioned, as people get older, the yellowing of the eyes occurs, especially the yellowing of the lens, so it makes it difficult, basically, for us to get more of that light back onto the fovea where we want it to be. discussed that a little bit, and I discussed that. So I think that covers things for visual perception. I'll look forward to talk to you about the next topic, the next lecture around.